Hello, class. This is the homework session as promised for chapter 21. Let's go ahead and get started with question 24. The highest frequency that humans can hear is about 20,000 hertz. What's the wavelength of sound in room temperature air at this frequency? A. We use our formula that V equals wavelength times frequency. We can rewrite that as that the wavelength is equal to speed over frequency. Well, the speed in air is 340 meters per second divided by the frequency of 20,000 hertz, which is the same thing as cycles per second or per second. So this will equal 0.017 meters, which is the same as 17 millimeters, 1,000 meters, 1,000 millimeters in a meter. And what is the wavelength of the lowest sounds we can hear is 20. So that wavelength is equal to 340 divided by a 20 or 17 meters. The answer to 24 is C, as in cat. A violin 25. A violin string playing a note A oscillates at 440 hertz. What's the period of the string's oscillation? Remember that if you know the frequency, you know the period. If you know the period, you know the frequency. A, they're reciprocals of each other. So if I take for 440 hertz, which is cycles per second. Again, the cycles don't count. The same as it over 1. Take the reciprocal of that, and then that will equal equal 1 over 4, and this is in seconds. Hence, that the period is equal to 1 over frequency. And the answer for this one will be Z as in zebra. Again, for 26th, the string of a cello playing note C oscillates at 264 hertz. What's the period? So this period is equal to 1 over the frequency. And so that is 1, 2, 6, 4 seconds. And the answer to this one is F as in foxtrot. How much more intense than the threshold of hearing is a sound of 10 decibels? So for 10 decibels, we take 10. Remember, the threshold of hearing is 0. So 10 minus 0 equals 10. Divide that by 10, which will equal 1. So it's going to be 10 to the first power. Times. Then for 30 decibels, we have 30 minus 0 equals 30. Divide that by 10. That equals 3. 8. Then we raise 10 to that power. So that's going to be a 1,000 times. And for 60, it will be 60 minus 0 equals 60. Divide that by 10. That's going to equal 6. Then we raise 10 to that power. So it'll be 1,000,000 times more. And the answer for our 27 is A as in alpha. How much more intense is the sound of 40 decibels than 0? So we have 40 decibels minus 0 decibels, which is the threshold of hearing, equals 40 divide that by 10, and then we raise 10 to that power, so it's a 10 to the 4th, or 10,000 more m-tenths. And the answer to 28 is D as in dog. 29, how much more intense is the sound of 40 decibels than the 30? So we take 40, subtract off the 30, that equals 10. Divide that by 10. That, of course, equals 1. So it will be 10 to the 1st. And then the answer to 29 will be S, as in Sam. A certain note has a frequency of 1,000 hertz. What's the frequency of a note 1 octave above? An octave is a factor of 2. So 1 octave above will be twice as much, or 20, or 200, no, 2,000. What, 2 octaves above? It'll be another factor of 2. 2 times 2 is 4, so it's going to be 4,000 hertz. And 1 octave below would be a factor of 2 below, or 1,000 divided by 2, or 500. Hertz. And 2 octaves below would be 250 hertz. And that answer to this is going to be M as in Mary. Consider 3 notes. 220 hertz, 440 hertz, 660 hertz. Write them from highest to lowest for pitch. Pitch is related to frequency, so it'll have the same order. So if we call this A, this B, and this C, our order will simply be C, B, A. For frequency, well, that's the same thing. C, B, A. But for wavelength, remember, since we're not changing the speed, the higher the frequency, the lower the wavelength. So it's going to have just the opposite. So it's going to be A, B, C, and the answer for this one is going to be T, as in Tom. Okay,